Hi everyone and welcome to another video. In this video I'm going to cover some of the advanced troubleshooting graphs and information available in vCenter for vSAN. I'm going to talk about the CeIP settings, what data gets sent to VMware and how that data that gets sent to VMware can be seen inside the vCenter in some of these advanced troubleshooting guides, etc. This is mainly performance focused. I'll go into some of the graphs in detail but not all of them, so if you want more information on some of the statistics and information we're looking at, stick it in the comments below or talk to someone from VMware or just have a bit of a Google. You might find some good information out there in some of the performance troubleshooting guides. Before we get into that, if you could just click subscribe and like on the video, it'd be really appreciative. But let's jump into the vCenter. Excellent. So once we've logged into our vCenter, we can then browse to the cluster level. This vCenter here is part of the VCF nested lab I've deployed. I'm going to do another video talking about how to deploy these nested labs using the VMware VLC tool. It's not really a VMware tool, but it's made by some people at VMware. So I'll go over some of that and how that's made, etc. This is how I deploy my labs. Some things turned on, some things turned off based on what I've been doing previously. So once we've logged in, if we want to go and see, first of all, from a vSAN support perspective, if we have something called CeIP enabled. To do this, we can go to Monitor at the cluster level. We can scroll down to our vSAN section that starts with vSAN Health at the top. We just click on Support very simply. Now, CeIP is the customer experience program from VMware, but it also allows us to be able to collect data from the vCenter in an anonymized fashion. So data sent to VMware, it contains nothing that's specific to the organization like name, IP addresses, asset tags, CMDB information, IP addresses, names. It doesn't location, it doesn't contain any of that information. So it goes to a VMware system and it's stored in a secure way. If you have any questions around how the data is secured, what's collected, speak to your VMware representative. But for a support perspective, it's great to have that data, because if there is a problem in the environment, say you've had some vSAN latency or you've had a disk acting strangely or you've experienced something odd and that's passed, the likelihood is that it'll be captured in the data that's reported to VMware. Now, there are gaps in this data. Sometimes it's classed as low priority. So if something is happening in the environment that takes priority, then this data won't be reported, but it will still be logged in the online logs. For someone at VMware to be able to access the data, they need this really long unique identifying number here. So this support tag will be given to the VMware architect, GSS support, or whatever, whoever you're dealing with. They can then go to the VMware system, use this tag, it pulls the data. The data still contains no information about you, IP addresses, names, and none of that information is stored. But if that is needed, you can click here and download something called an obfuscation map. Well, if you give this to the VMware representative, they can load this into the environment, and this is like a secret key that then unlocks the information inside the data that's reported back. So this will basically map the unique identifying numbers and names that are given to the data that's reported back to something that's meaningful in your environment, and it will help troubleshoot some elements. It's not necessarily always required, but it is often helpful for support guys. If this isn't enabled, it is in my environment, but if it wasn't, you'd come in here, you can enable it, and then it gives you some checks about how to, whether it's going through the firewall and things like that, so you can review all of that. What we want to look at is, and what one of the requests from many customers when they saw the data that was collected using this information is, how could they see the same data? So the data that's collected by the CeIP system that VMware can review shows your cluster, your number of hosts, number of VMs, whether you've got things like DRS, HA enabled and the settings around those, advanced options configured for those as well. It mainly focuses on vSAN, so it will show the disks, the disk group layouts, the model, firmware. It shows all of the results of the vSAN health check, and it also gives you or gives the VMware representative really, really detailed performance analysis information of each disk inside the environment, from cache to capacity, at disk level for throughput, IOPS, latency, even power usage. It gives them information on network usage for the TCP stream. For the vSAN, it gives them information around the CPU worlds that are used. It is really sort of granular engineering type performance analysis data. But a lot of people want to see that. So in the newer versions of vCenter, we've added some of this into this performance for support section. But you can use this for some of your own troubleshooting and for some of your own monitoring possibly as well. We click on this section here, it will load into the environment and we'll walk through each of the points quickly. The first screen you'll be met with is the DOM client. Now, if you want to know more information about how DOM works, Wikipedia is great. It'll give you some good information about how the object-based storage management system works for that. We're not going to cover that here, might cover that in a video later on, but if you want to find out about that, go and look over there. If you click on this option here, a lot of people miss this drop down. If you click on here, you can see all of the options that we can go through. So we've got different things for DOM client, we've got things for the DOM owner, we've got lson section here, network, memory, we've got commands, CPU, cluster vsync, etc. And then we've got the options that are reviewed in each of those dashboards. First one you'll meet is DOM client, and it gives you a good overview of the latency that's seen at a data store level in a cluster. So we can see here that my environment is nested and I was doing some resyncs to generate some data. We can see that we've got read and write latency of massive values. Now, what you would expect to see here is nothing sort of higher than 5 or 6 milliseconds. Anything higher than 5 or 6 milliseconds on the data store is when the VMs will start to experience some latency in the application. You can see the IOPS, and if you run your mouse over each of the graphs, you'll notice it lines up a line on the other graphs as well. Hopefully you can see that on the video. Congestion's a good one to look at, because this would be a clear sign that there is some issue in the environment. But for now, we're just diagnosing a bit of slow performance that we had at the time when I was doing a resync. If we scroll down, it starts at the cluster level here. We collapse that. If we scroll down, we can then see each host. So we've got the data store level latency up here, and then we've got the latency that's seen on each host that contributes to that cluster-wide latency. We can see IOPS as well, so the cluster-wide IOPS are then broken down into the IOPS that are seen, and the throughput, and the outstanding I/O, and the latency deviation. Now this is the read and write latency combined, rather than having them separated as we do in the top graph. Same sort of thing on each host. You don't want to really see any more than 5 milliseconds latency. If you do, then you're going to start experiencing challenges. We're not going to go through every dashboard on here. What I'm going to go through is lson. So lson is one of the first areas that most vSAN troubleshooting scenarios will focus on. So we'll look at the DOM client, we'll look at and normally see where there's latency in the environment. And one of the first places we would look for that latency would be the cache disk. So we can go to lson and we can select cache disk. Now this is going to display each host. We can see at the top here, and it will display each cache disk located in each host. So in this environment, I have 2 cache disks in each host. So we can see we've got 2 cache disks in each host that are configured. Oh, sorry, no, 1 cache disk in each host. I'm thinking of another lab I deployed previously. So we can see we've got 1 cache disk in each host, and then we can see on that cache disk the IOPS, the throughput, the latency, the hit rate, and more importantly, we can see the write buffer. Now this is where we would focus mainly most of our troubleshooting. On the write buffer, we can find somewhere further down, we can see that we've got 4 lines, and if you run your mouse over it, you can see that it'll give you 4 things on the legend as well and on the key. So the green line we've got here, this is our destaging point. So when the cache becomes over 30% consumed, we will then start to exit data out of the cache to put it to the capacity tier to allow more data to hit the cache. Because if the cache fills up and data is waiting to hit the cache, vSAN will delay the write confirmation to the application, and the application will see storage waits or storage latency. Now the line along the top, the purple one that you can see, that is the consumption. So you'll see the 30% consumption at the top here, and then this one along the top here, it's 30% consumption on the green, sorry, and then the purple line along the top will start to decrease because that's free space. So as we fill up, we use more space, so the free space starts to decrease. What we don't want to see, and what we see in some environments, is these 2 lines crossing. If these 2 lines cross, then that means that we are confirming data to the cache as soon as we're accessing data out of it. So the cache is then overwhelmed, and that can be caused to a number of challenges in the environment and would go into more troubleshooting. But for the purpose of this video, this is to demonstrate that if we've got a performance problem and we can see that the cache is full, the green and the purple line are hitting each other, then that's where our latency is being introduced. Device latency is also something else that we would look at. So device latency is really interesting because this can be caused by a number of things. It could be things like the device endurance. The device could have bad cells inside it and could be close to dying, which would cause latency in confirming and requesting read and writes from it. And also it can be related to power management. One of the key things that a lot of vSAN environments that we review haven't got configured is the P and C states in the power management. And this allows the CPU to be able to better manage the power inside itself, but also be able to manage things like the PCIe lanes that some of these NVMe disks will run off of. So if we're powering a disk down or reducing the power to it because we're trying to do power management at the wrong level, or we haven't enabled power management in the right place, and the cache disk for some reason has the power reduced, it's then going to take longer for it to respond because it has to ramp up the power and then respond to the write or read request. So power management is key in trying to reduce some of this device latency. The one here, because it's a nested environment, is pretty bad. We don't really want to see anything higher than, we don't want to see that in the milliseconds. We wanted to see it in the nanoseconds or ultraseconds, or we want to see that figure in. So we found out that if we're looking through some of this information, that we've got a write buffer being full. One of the other things we might want to look at, what we see in a lot of environments, is CPU. So if we look at the CPU on here, we can look at the DOM and the lson CPU worlds, or we can look at the vSAN CPU. So for now, we're going to look at the vSAN CPU for this demonstration. And this will show us how much vSAN is consuming in the environment. So we've got percentage used and percentage ready. We can see in these environments, each host is listed, but we've got a deviation slightly in some of the amount that we're using and some of the amount and the wait times as well, and the ready values. This would be a good indication if, say, for example, the environment is oversubscribed, the consolidation ratio is too high, and vSAN is being not getting the CPU runtime that it needs. Utilization might not be a problem. Many vSAN environments we see utilization is fine, but runtime onto the CPU can be a challenge. Further ones inside here that we would also look at, going back to CPU, is lson. So if we're looking at the lson CPU usage, this is the CPU being able to run the process called elevator, which is our destaging process, which will then take the data out. And if you've got something like deduper compression enabled, it will then do the deduper compression or encryption action, and then it will commit it to the capacity disk. We can see figures in here. These figures are very minimal because, again, it's a nested environment, but if we saw high figures in here or lots of deviations, then that would be something that we would want to investigate as well. Again, could not necessarily CPU utilization, but CPU runtime access that could be affected. Another key one we would look at would be focusing on some of the actual capacity disks. So if we go back to lson, we look at the capacity disks, we can have a look and see how they're performing as well. Some of the values are similar to what we would see in the actual cache disk as well. So we can see each disk in each host, and then we can look at the device throughput, latency, and the plog. Plog is the destage, how quickly it's being written to the capacity disk, and how much data is being written. So we do have a plog latency graph that we can see inside some of the data at the back end. It is available here. I'm not sure under what option, but that would show you sometimes if there's waits, etc. You see a lot of throughput on here. This means that disk is getting a lot of data written to it for destaging. You can see if we've got a lot of device latency, same sort of thing as we said before with regards to the power settings, or the device being degraded or having bad cells, etc. We can see throughput, and we can see this is for each disk inside the environment. Now, as you can see on here, there are loads of options to go through with regards to some really sort of detailed information. I mean, we've even got DDH disk, which is our dynamic disk handling information for detecting if disks are failing or having challenges. We've got memory utilization as well that we can look at for the host. We've got commands that we can look at with regards to that. Networking is one thing that we would also look at, and we can look at the physical network. The TCP/IP stream, like I mentioned earlier, is normally where we would see some challenges, and we would focus on for vSAN. So in this information here, we can see exactly what vSAN is sending with regards to packets, throughput, and TCP transmission. TCP connections is a good one. Congestion and errors are one that we would also focus on. My environment being nested is relative, doesn't have any errors or congestion, but we can see sometimes TCP congestion on here, which is our send zeros. These are pauses being issued by either the host or the network device upstream. Sometimes when buffers run out or when a device is overwhelmed. So this would be a key indicator into latency as well. If we're not able to send or receive network data, because vSAN's a network storage solution, then we would see that translate into latency because we can't confirm or receive the packets. TCP errors is also another good one. One of the things we look at in here is out of sequence packets. So if we see a lot of out of sequence packets alarms here, this would indicate again that the switch is not able to handle the transmission of the vSAN data. That's all I'm going to cover in these graphs today. Definitely take a look for them yourselves. Have a look through all of the settings we've got here. Anything that you don't understand or have questions about, there is lots of information on Google. You can speak to your VMware TAM or GSS or PSO representative, or even reach out to me on the comments on this video, and I'll try and help where I can. Going to close the video there. Thank you for watching, and appreciate your support. Have a great day.